Hello and welcome to the Friday, August 15th, 2025 edition of the SANS Internet Storm Center's Stormcast. My name is Johannes Ulrich, recording today from Jacksonville, Florida. And this episode is brought to you by the SANS.edu Bachelor's Degree Program in Applied Cybersecurity. And talking about our bachelor's degree, we do have another guest diary by one of our undergraduate interns. This time, Joseph Noah is writing about how AI tools help Joseph to better understand some of the events during the internship where our students are typically analyzing alerts that they see in their honeypots. This particular case looks at some issues like, for example, analyzing logs or analyzing little scripts that were found by the honeypot. So, for example, better understanding what certain commands mean, do, and how their impact may necessarily sort of affect the particular honeypot environment system. Here we have a very typical example in this blog post about a command injection attack and details like the no hub command, for example, in Linux. What this does, it's, yes, you could probably figure it out with Google as well, but much easier to sort of get it explained in context by various AI engines. As usual, in particular, as a beginner, be careful, verify your results, that you are not sort of ending up with a very plausible but wrong hallucination from the AI system. And OnLab is reporting about an interesting new way how Proxyware malware is being distributed. In this case, it's a YouTube video download site. What's happening here is that you have websites that allow you to essentially quickly download a YouTube video, the actual video file. One example here is YTMP4, basically YouTube MP4. You provide it with the YouTube link, and in turn, you'll be able to download an MP4 file with the video, or at least that's sort of how the site is supposed to work. In this case, what you end up with instead when you're downloading this file is, a malware. You are ending up with a setup script that will then install the Proxyware. If you're not familiar with Proxyware, it's not a type of malware we're really talking a lot about, but it's certainly quite popular and common. And it is basically used to turn your PC into a proxy. And then the attacker will essentially rent out your PC to allow other attackers or just people who want to watch sports online or such to actually use your PC essentially like a VPN via the installed proxy. This often has then, of course, detrimental effects on your system. And of course, they can at any time also install additional malware on your system. For the affected user here, this is probably one of the sort of, less critical piece of malware that you could possibly have on your system. But keep in mind that it's often used for illegal activity, which of course then may also get you in trouble as the traffic is being reversed back to your IP address. And Horizon 3 is at it again with a great write-up with details regarding vulnerability, actually two vulnerabilities in Xerox's FreeFlow print management system. This particular set of vulnerabilities, it's an external XML entity vulnerability as well as a Path Traversal vulnerability, will get you full remote code execution on the vulnerable system. I particularly like the discussion here of the external XML entity vulnerability because I think they're, actually quite common, but often overlooked and not really sort of often well understood as far as what their severity goes. So definitely a good write-up here if you're not using Xerox's FreeFlow Core. If you are using Xerox's FreeFlow Core update now, the patch for this vulnerability was only released, I think it was last Friday, was on August 8th. Well, and it's Friday, and I have yet again another SANS.edu student to talk about their research project. Darren, could you introduce yourself, please?
Yeah, absolutely. I'm Darren Carstensen. I'm one of the MSISE graduates and a fellow coworker in the security realm.
Are you done with the degree now,
I'm sorry.
or?
I am. I just
Okay,
finished
good,
up
good.
last month.
And so people can trust you now, but your paper was zero trust. So what was the paper about? Can you just summarize that a little bit?
Yeah. The paper was born out of a bit of frustration I had, where I was being tasked with helping solve customer problems, and one of those was around zero trust network access, which in the name implies zero trust, but I found in reality there was some big differences in what was actually being executed. So I decided to build a research paper around how you can actually measure the amount of zero trust in a zero trust
So
network
great.
access solution.
And now zero trust, of course, one of the problems is it's well, actually not as much anymore, but at least used to be one of those hot topics. And now it's how to use AI in zero trust. But the and there were sort of a couple of definitions going around. In your opinion, what's sort of one of the critical things from a technical point of view that you look for to see if zero trust is actually implemented?
Yeah, it's basically going back to understanding that you need to, go away from the trust but verify principle and move more towards the never trust, always verify, and be doing that across the entire IT spectrum. So not just focused on doing it in networking or only in identity, but doing it across really the five different pillars, which would be identity, devices, networks, applications,
So
and data.
how do you measure this? Like we always look for something you can measure in our research papers.
Yeah, so I mean, ultimately, the government, the Cybersecurity Infrastructure Security Agency, or CISA, came out with a decent way of measuring your maturity level within zero trust, and they call that the zero trust maturity model. Version 2.0 is the latest iteration of that, and it really helps break down not just are you doing zero trust, but at what maturity level are you at? Going from just one example is, okay, say you're doing identity security practices and you have multi-factor. That's great. But do you have things like phishing resistant multi-factor authentication to help measure, oh, you're not just doing MFA, but you're doing it in a better stance than everyone else that's
And
also
actually,
doing
that's
MFA?
sort of a little bit a favorite topic of mine right now. That's the phishing resistant part. Can you just tell us quickly how common multi-factor authentication is not phishing resistant?
Sadly, it's still, I would say, fairly common from my perspective, what I've seen in with the real world and in production environments. Some cases, it's legitimate reasons, like we've got folks that don't have equipment that can support that. Other times, it's cultural, but oftentimes we still see, allowing things like SMS, allowing things like basic push notifications that don't have a lot of context or data or information presented to the end users. So I feel like in the number of conversations I have with customers, it's almost 50-50. Folks that are beginning or are doing some phishing resistance, but also the other 50% still
Yeah, and
are
what about
not.
phishing resistant multi-factor authentication that look like?
It gets rid of a lot of some of the older things that can be taken advantage of. The easy and common example is around SMS messages that would give you those one-time passwords, where essentially it's giving you that password, but oftentimes people will phish or vish users to try and get that token and get them to pass that on to the attacker so that they can leverage that as well. So moving away from that and moving more towards things like biometrics or even push notifications that can include more context, like it's this person's identity coming from this geolocation at this time, this IP
Yeah,
address,
yeah,
giving
yeah.
at least more context
So
to it.
phishing is like one of the attacks here that Zero Trust kind of tries to address. Of course, no, we're not implementing security controls without any real threat that we're actually blocking here. As part of your research, what type of attacks did you consider?
So I tried to cover a variety of different things. I went through each one of the pillars and just picked a simple, relatively simplistic example. And it ranged from identity on that side. I did some simplistic things like, can we just do role-based access control? And then also, can we do step-up authentication with multifactor to say, oh, if a user is accessing a sensitive resource, can we, based on that sensitivity, do step-up authentication? I went into the device side and measured, okay, can we evaluate, does the device have disk encryption? Does it have healthy endpoint protection and antivirus definitions? I went into other areas, and one of the more interesting ones, or two interesting ones, was around the application layer, where I did some SQL injection to see, is it application aware? Can we actually see what's going on there? And also passing malicious content to see, can it identify when someone's passing in one specific instance, like a interpreter payload or a reverse shell payload? Is that able to be detected and picked up upon? Are we looking truly at the payloads? And then the data layer, which I thought was going to be straightforward, was looking for data loss prevention. Can we just pick up simple things like PCI or PII data, which is pretty common in most environments? And can we do some actual detections and preventions and blocking around that when it's being transferred?
That last step with data loss prevention, how did that go?
It was a little bit surprising. I picked 5 different vendors. 3 of them are leaders in the zero trust network access space. And then I picked a more niche one, and I picked a small, medium business one. Almost nobody was able to pick up on the data loss prevention. And the simplistic test that I had established was a remote user just trying to access and upload and download sensitive data from a Windows file server, using SMB protocol. And only one player or one provider out of that space was able to actually do the PII and the PCI, but they didn't pick up on malicious content. And the one provider that I thought was going to be the most robust, because they advertise having enterprise DLP, and I put that in air quotes, their enterprise DLP only covers HTTPS traffic. So they completely missed the sensitive data being transferred over a Windows file share, which kind of was,
I guess, once you get to zero trust, I guess they assume that you blocked port 445.
Or maybe they just assume nobody does Windows file shares anymore. That's
probably
legacy technology.
These days, you never know. Yeah, I have seen like the DLP, of course. A lot of people joke a little bit about DLP. It's hard. It's a hard problem to do. Like sometimes, even if you do look at HTTP HPS, then you look at WebSocket and some of those things that can still be used for exfiltration, even if you are fairly tight. But so did it at least show who did it? Kind of, because that's the other games with zero trust is that authentication part. If it doesn't prevent an attack, does it at least show who originated the attack? Or
in some cases it did. I was able, in some very unique situations, where you could see the logs and the audit record of what Darren was doing when he was transferring some data. So even if it didn't pick up that it was malicious or that it was an attack, you could at least go back, and if you had some other, like a SIM or some other analytical tool that would pick up on that, great, the data was there. But in some cases, it wouldn't even identify that, and it wouldn't trigger, and you wouldn't have enough insight. You wouldn't have enough logging context to be able to put that together.
Well, there's more detail in the paper, and the link to the paper will be in the show notes. But any final words? Is it worth doing zero trust? Or
I think it's absolutely something that some of us are doing naturally as security practitioners. I don't find enough folks are doing deeply enough. They were like, oh, I bought a product like Zero Trust Network Access, so that checks the box, right? It has zero trust in the name. So the one takeaway that I would recommend or put out there is that again, kind of like zero trust implies, don't trust, try and verify. And if you're looking at solutions that are going to increase your security and reduce your risk, test it out. Evaluate it against your environment or your own criteria, and confirm that it is going to meet your expectations, because oftentimes the marketecture, as we call it, is ahead of where they're at from an execution standpoint.
Great final words there. So again, the link to the paper will be in the show notes. If anybody's any questions, there's also contact information for Darren in the paper. So thanks for listening, and talk to you again on Monday. Bye.